In this video, I will be explaining delta H, Hess's law, and enthalpy. Enthalpy is the heat or energy content of a system at a constant pressure. Hess's law means that heat involved in a given process can be expressed as the sum of the heats of several processes that, when added, yield the given process. Total heat, or delta H. The delta H of a reaction is the sum of the product's heat minus the sum of the reactant's heat. If the total heat of the reaction is positive, the reaction was endothermic, and if the total heat of the reaction is negative, the reaction was endothermic. So the first thing you need to do to solve this is mark all of your standard enthalpies. Okay, so we know our equation is the sum of the products minus the sum of the reactants. So we need to label those and write them all down in our equation. We have to remember to multiply HCl by 2 because there's 2 in our equation. Okay, so we type all of this into our equation, we get negative 633.86. So that tells us that our standard reaction enthalpy for this equation was negative 633.86. So this is our delta H. Because our delta H is negative, that means that our total heat for all of this went down. So that tells us that heat was lost by the system. So that makes this reaction exothermic.
Enthalpy change is calculated by subtracting the products by the reactants. In this case, the reactants would be SO2 and oxygen, and the products would be SO3. In order to calculate the reactants, you would multiply 2 by negative 16.9, and then we would add that to oxygen, which would be 0 because it's a pure element, which equals negative 33.8, and then you would have to find the products, which would be SO3, and then you would multiply negative 21.9 times 2 because there are 2 moles of it. which equals negative 43.8. And then to calculate the enthalpy, you would subtract the products by the reactants, which would be negative 43.8 minus negative 33.8, and it would equal an enthalpy change of negative 10.
Our starting temperature of ammonium nitrate was 23.3 degrees Celsius. We added water to the ammonium nitrate and stirred. After stirring, our temperature of ammonium nitrate was 1.9 degrees Celsius. This tells us that our reaction was endothermic and that the change in heat of ammonium nitrate was positive. Our starting temperature of calcium chloride was 23.3 degrees Celsius. We added water to the calcium chloride and stirred. After stirring, our temperature of calcium chloride was 77.9 degrees Celsius. This tells us that our reaction was exothermic and that the change in heat of calcium chloride was negative.